In this video, we're going to look at finding the limit of a piecewise function. So we have a piecewise function, x squared plus 1 if x is less than 0, f of x equals 3 if 0 is less than or equal to x is less than 4, and f of x equals x minus 1 if 4 is less than or equal to x. So we are going to look at the two breakpoints. We do have this function is what we call piecewise continuous. We've got polynomials in each of our pieces that are going to be continuous. The only place where this might have any issues as far as the limit is going to be at those breakpoints when x equals 0 and when x equals 4. So the first thing we're going to do is take the limit as x approaches 0 from the left. Now if we are looking at from the left, that means we are always less than 0. So that means we're always in this first category. So our function f of x is always going to be equal to x squared plus 1. Well, as we approach that from the left, we can plug in 0 for x, and we get that that limit is equal to 1. If we're approaching it from the right, well, from the right, that means we're always bigger than 0. That means we're always in this middle category. And so our function is just the constant function 3. And so the limit as x approaches 0 from the right of 3 is 3. Our y value is constantly 3, so it doesn't matter what x value we plug in. Now, it doesn't matter where the equal to, or even if there is an equal to piece here, what we're looking at are these two numbers right here. Since these two numbers are different, that means that the limit as x approaches 0 in general does not exist. So since 1 and 3 are not the same, the limit as x approaches 0 does not exist. Now if we do the same thing for x equal 4, here we're looking as we approach 4 from the left. Well, 4 from the left, that didn't work out too well. Approaching 4 from the left, that means our function is again constantly 3. So the limit as x approaches 4 from the left of our f of x at that point is the constant function 3. And so there is no x here. That limit is always going to be 3. And then if we approach 4 from the right, that means we are looking at the x's that are bigger than 4. And so we're always in this bottom category. And so the limit as x approaches 4 from the right is going to model that bottom function, x minus 1. And so that we can plug in x, we get 4 minus 1, and that is equal to 3. And then to find the limit as x approaches 4 in general, we're looking at these two numbers right here, the limit from the left and the limit from the right at that value. And since these are the same, that means that the limit in general is that common value, x equal 3. So in this case, our function would connect when x equal 4, but it would have what we call a jump when x is equal to 0. All right, I'll see you guys next time.